of what is the background, but the special thanks. I'm working as an associate professor in Tech Mahindra University. So very fortunate that wherever we have been asking government to help us, they've been giving us the bridges to test. It's not that easy to go to the bridges and test. They were giving us the trains, bridges, buses, everything. So Indian Railways, NHI and the Ministry of Road Transport Highways, they are giving us all the support to do all such kind of tests. So special thanks to that. And another thing, one of the most important thing in civil engineering is to have a collaboration between a research organization and a company. So this company had a real-time problems, and when I returned back from Japan after doing a system, we had a lot of solutions, but we didn't know where to give. So this was the company which asked the problem, so we bridged. We had this MOU between Mahindra University and KDM, and that's how we started our journey in 2018. Okay, it all started when we were in 2017 in Japan. One of the cause was, China was constructing too many bridges in a year. And every out of 100 bridges, there were at least 10 to 13 of the bridges were not behaving exactly the designer wanted. We build bridges because we want them to act like the way we want. So there was a lot of some kind of functional utility. So you can see the kind of challenges. Mammoth structures. After the completion of complete bridge, to repair a retrofit, it is a very big challenge again. So for such kind of a bridges, the Chinese government has asked the Chinese researchers, can we come up with something technology, and when we put somewhere in this bridge, so that from the day one we will know that there is some problem in the bridge. That's where it started about embedded sensors and sensors. So now in certain countries we are putting sensors which will tell us from the day one, okay, there is a bolt function here, there is an elevation problem, there is a problem in the joint. This is where we are heading into. And the second, like many countries are building many of these flyovers and bridges. Even in India also we have approximately 2 lakh bridges, more than 2 lakh bridges actually. But how do we maintain these bridges is one of the very big challenge. Person going to the bridge every time and getting the maintenance and how to see how is this bridge is one of the most challenging thing. So right now, in fact, we are investing on something called taking drones there, and we are able to tell how many different types of damages are there, whether this bridge is healthy or not. This is the kind of research we are also trying to do. At the end of the lecture, I'll show you a couple of pictures. So this is fair use. I said I'll put this presentation maybe for half an hour, not take much of time. Bridges, this is IVRCL tower, IVRCL, one of the company which was constructing major bridges in India. This is in Kolkata, which is one of the major failure during the construction. You can see this. And this was not during an earthquake. This is while traffic was going, one of the bridge has failed. This is in Himachal Pradesh, and this is in Mahanad Bridge in Savitri. Now in all these 3 bridges, India has every 100 bridges, we have at least 6 or 7 bridges undergo major failure, and around 20 bridges undergo minor failure, which means crores of rupees. So we just have to see how can we avoid such kind of accidents. So this is in Visakhapatnam, actually, this was in Visakhapatnam. There was a very small mistake they did. It was supposed to support itself on a wooden block. They kept multiple wooden blocks. One wooden block has slipped, and actually one person also have died. This is in Visakhapatnam, and this is Mahanad Savitri Bridge, and this bridge was assessed and said by the agency. They said that okay, we have tested this bridge. Now this bridge is okay for the traffic. But after exactly a month after it was tested and licensed and certified to allow the traffic, there was a flood. And then there were 28 people, there was 40 people going in a bus and it got flooded away. 28 people have lost in this bridge. So suppose the whole question right now is, can we tell that this bridge is going to collapse in a day, in a month, in a year? Can we tell that? The whole research was under that. So to the surprise, Indian government, which is like CSIR, CRRI, was doing a research. How many bridges are there in India? How many bridges are there in India? Average Indian age or average Indian generally these days live at least till 70 to 75 years. That is an average age where people live. Indian bridges, when they did a research from all the bridge failures from 1977 to 2017, one of the surprising fact they found was Around 2130 bridges have failed and the average age was 34. If you are all from civil engineering background, you should know that the bridges are designed for 80 years or 100 years. But the average age of failures is 34, which means that we are already losing 65.5 years of age in a bridge, or approximately 50 to 60 years. Before the age of 56 years, they are dying. So now what are we supposed to do? So Indian government has come up with something called Indian Bridge Management System, where they wanted every bridge data to be assembled online. They wanted every data of the bridge, like they were telling geotag of all the places, houses, everything. They wanted every bridge to be, the information to be there online, so that they can see which bridges are good and which bridges are suffering from some kind of a repair or some kind of a damages. So they got all this data and we did 600 bridges. Maharashtra, Madhya Pradesh and Gujarat, we were also part of the government project and we did around 600 bridges. I am not getting into the pictures, but we found out a lot of challenges. But question was, we got the data in 2016 and 17. How do we update this data every year online? Is a question mark. Do you know Aadhaar card? I think you all have Aadhaar card, right? Aadhaar card is the data of all the people online. Everything about you is there. Like that they would like to have bridges. But Indian Bridge Management System, they wanted to update this data. And accidentally 27 states or 26 places have did in a different ways of getting data. So they were not able to combine everything online. So they had to scrap this project. Now they have started another Bridge Health Monitoring System of India as a new project. So the whole challenge was, how do we keep the data updated every month or every 6 months or every year? That was one of the big challenge. How do we update this data? So we have given this presentation to the Indian government. Let us put a small sensor. If you have traveled in a car, if you open the door, do you get a signal, alarm? You get an alarm, right? If you don't put your seat belt, you get an alert. Suppose what if you put a one small sensor on all the bridges and able to get the data of this and it is being updated online. So this is what is instrumentation. So I am not getting to all of these things, but we were largely doing vibration analysis. I will tell you in small piece. This is all NDT techniques. Again, I will not get into this. NDT simple is all about, without destructing the structure, we are able to get the material properties. Either it is homogeneity, or it is integrity, or it is voids, or it is compression, anything. So this is what is NDT testing. And we told that by touching this, can you hit like this and can you know whether this is hollow or not? We can know, right? By just hitting, we know whether it is hollow or not. In the same way, I can hit here, I can tell this is a wall. In the same way, our sensor will just give some kind of an excitement and we know what kind of a material it is. It's not our sensor, basically. So there are a lot of such kind of sensors. I am not getting back into the sensors, but these sensors can tell us whether the building is settling, uniformly, non-uniformly, or there is a problem with the foundation, inclination, rotation, crack and everything. All such kind of sensors are currently available. All we need to do is put these sensors to the structures. Now this is what is the first test we did. For you, this is for civil engineering, one of the most fundamental example is a cantilever. This is a cantilever, and in laboratory you can also try anywhere here also. We use something called ADXL sensors. This is an Arduino and ADXL sensor, and we have connected this. Remember one thing, if I am hitting this, if I am hitting harder or if I am hitting slower, the frequency of the vibration will remain the same. The frequency or the vibration of this structure will remain the same. So that frequency we are getting in this term. So whatever force you apply, the frequency which is called characteristic of that building or bridge will always remain the same. So that is what we are trying to do this, and this is what you can just see here. So if you are hitting this, how hard you are hitting this, you have a vibration. So you can hit anywhere on this object, but when you convert that into frequency is number of cycles per second, that frequency for this system will remain the same. So that is the basic concept of whole of this structural health monitoring of structures, what we are diving into. So this is the laboratory experiment, and same thing. The second thing, Suppose you might ask me, how do we differentiate between if this has a damage or no damage? So anyway, these are all numerical and frequencies. I would like to tell this. The bridge is undamaged as a bridge which does not have a damage has got this frequency, and if you put damages elsewhere in other parts of the bridge or cantilever, your frequencies will change. Now based on this frequency, I can tell whether there is a damage in the bridge or not. And based on this also I can tell where exactly the damage is. Currently we are still doing research how severe the damage is, but we are able to tell the presence and location of the damage. So this is the experiment which we did with different types of cantilevers. We did more than 120 different cantilever beams by putting a damage and not damage, and we calculated the frequency. Now with this we are able to tell to the government that this is only small presentation. We gave a detailed presentation that we can tell that there is a damage in the bridge, and we can tell the location of the damage, and we are also able to tell the severity of the damage to some extent. And right now we are trying to tell what is the remaining life of the bridge. This is the whole idea of this one. How long this bridge can live for the current given loading conditions. That is what is the residual life or prediction of remaining life service. So I will tell you some. This is I am sure you know Vijayawada, right? Vijayawada. This is a flyover which was constructed, 5.3 kilometer flyover, Kanakadurga flyover, one of the longest flyover. And this is case study from that. This is very beautiful evening times. Even now also you can travel on that. Now what we found was when they were constructing, they asked us that while they were installing certain segments, these are called wings. Now it has got a spine, is a pier. You have a spine and you got two wings, one side this and this. This is a cast. So this is a spine, this is a wing. And when they have seen cracks on this. Now the question is, can we install the segments in the bridge? This is not one segment, but they have seen around 60 to 70 such kind of segments. And they asked us, can we put this? And they asked us, what is the reason behind such kind of a cracks on these segments? So we went to the site, we do something called forensic structural engineering, forensic structural analysis. Now if you see the diagram, this is the wing. If you are civil engineering, this is the wing. We have tested and we found that concrete was M60 grade, and when we tested compression strength, we got 72 Newton per mm square. We tested design also, design was very good, material was good, casting was also very good. Then what was the problem was, they said that during pandemic, you see this was supported on the ground, right? During the pandemic, people have theft these supports. People have taken away the metal part, iron part. So what happened, this was supposed to be a cantilever. When you leave this, it became a simply supported. Cantilever, you have a tension on the top. So when you remove the supports, it became a simply supported. For cantilever, you have more steel on the top. For simply supported, you have steel on the bottom. So what has happened here, because they have removed this, they have failed. So we did analysis and then we told them wherever they have removed these supports and they have put some small support and a sandbag here, and that made to the crack. The question was not this. Question was, what if some segments have already installed on the bridge? This were at the bottom, and we told them all in this 60-70 we can remove. But what if these segments are already installed on the bridge? Can we know that there are some segments which are cracked on the bridge? So that way we were trying to do that point of time, not getting to that answer as such. But this is the tension zone failure, and there were around 70. We have to remove all 70 segments. The second, now this is what is called something called digital twinning. Digital twinning means what? You have a bridge. I am a designer. I have designed a bridge, and we have constructed the bridge. Now, will this bridge take the load exactly I intend? Supposed to take some load. So what I am doing is this exactly the bridge which is constructed in the site. I am making the same bridge in my numerical model. So I am getting all the properties from the site and I am making a twin of this bridge in my numerical simulation. Here I will do all kinds of testing. Suppose you would like to go to a space. You won't go to the space and get a training. You do in a simulator. The same way, that is called virtual. So what we are trying to do is make a twin of the existing bridge. This we did in Japan. So these are accelerometer sensors. So you just, they are small kind of tiffin box. You just have to put it on the bridge, This is around 50 meter. This is the bridge, and this blue color location are the sensors. This blue color are the location of sensors. And you might ask me that how do you disturb the bridge? By simple, my friend was hitting the bridge with a hammer. You can just hit like this, take the vibrations, and that will give us the bridge property. As simple as that. It is not replacement of all NDT tests at all. NDT tests still are very good, especially to understand the compressive strength of metal. So either we can jump, maybe couple of Korean friends were jumping on the bridge. This has excited the bridge, and that excitement or that vibration we record. Now this is the designer's model. This is the bridge which is existing at the site. So this is the model. Designer has designed this. Now this is the model which is existing at site. Now after the construction I can tell, okay, this is the designer and this is the existing site. I can tell, okay, 10% or 20% of the bridge quality has compromised after doing this test. Now it became mandatory for all iconic cable stay bridges that this test have to be performed and checked, so that we can see what is the deviation between the one bridge which is constructed at the site and the one which is designed. So this, after once we get this, whatever values you get, you inject into this, which means whatever you get this behavior, you give this behavior to this model, so that will become your twin. So now whatever testing can be done on your numerical simulations, you don't really need to do at the site. This is what exactly we did for Vande Bharat train. Before Vande Bharat train was going at 160 km per hour on certain number of bridges, they asked us whether this bridge can be allowed for 160 or not. Then we did this kind of a testing. I'll show you a couple of bridges as well. So this is what is digital twinning, and this is what we get from the accelerometer sensors. These are all kind of a behavior the bridge can undergo. Different mode shapes we are trying to match. This is another thing. You know, Vande Bharat train is designed for 160, right? You all know. Have you traveled in Vande Bharat train? They go at 130 km per hour as a constant by average, 120, 130. Now if you see, in the older days and now, the railways are not segmental, they are continuous. We call them as something called continuous belt rails or long belt rails. You don't have a joint here. Now these rails are supposed to be continuous. Now when you have continuous rails, the major problem is during the summer and winter. It's not only in India, other countries also we have buckling and cracking. So the railways have asked us, can you put some sensor here or some sensors here after the train goes, and if a train is applying a sudden brake, can you tell is this affecting the bridge? This is what we did, and we kept, these are the sensors. These are a lot we imported from California. This sensor seems to be a very small one, but this battery charges around 6,000 each. We can leave at the site for 1 month. We don't need any kind of a charging for that. So there are 3 batteries, and this will absorb the vibrations in 3 dimensions. So this is the bridge we did. This is one of the, this is near Gulbarga in Karnataka. This is one of our first bridge where we have kept 16 sensors. I will not talk about FEM, but you can see there are sensors and rails. If a train is braking on the rail, how much rail is moving with the sleeper, how much sleeper is moving ahead, how much the whole deck is moving forward is also calculated in this. So this is called rail structure. And while doing the train testing, it is very important that temperature is very important. So we do in the midnights of the winter and mid afternoons during the summer. So you can see that, now you can see in this place we are putting our sensors. We asked us the train to stop on the bridge. Now when the train actually stops on the bridge and goes away, the bridge should come back to its own shape. You know, the name we call it as an elastic behavior. It should regain its shape. So we were putting some strain sensors to these rails and we were calculating. So first 1 year actually we failed during this testing, because these sensors, whenever the train is going at 100 km per hour, we are not able to get any kinds of reading. Then we have pasted all our sensors below the bridge. First we kept on the bridge. From the second time we kept all the sensors at the below the bridge. Now we have recorded this, and this is to the pier. Whenever a train applies a sudden brake on the bridge, you know, sometimes the pier can also tilt. So if there is, have you ever seen bearings? You know bearings, you heard of bearings? There is a bearing here. Wherever a train applies sudden brake, if a bearing is strong or if it is failed, then the deck will slip. The first bridge I have shown in the failures, such kind of failure will occur. So we did this testing and we have kept even sensors to the pier also, so that we wanted to know whether pier is tilting or not. And then these are the values from the designer. This is for your only comparison. Like suppose this cantilever can take 1 kilonewton. That is the design. But I am applying some load here and I am trying to test. So what are the designer values and what are the values we were getting from the site? We told whatever the designer is done, whatever the deviation is basically in this, the deviation varied from 8% to 30% at some cases. So that is the deviation. So now we are able to measure what is the stress and strain in this beam. Till now it is very challenging to measure the stresses strains in beams. But right now we are able to measure. Now this is online. We made our own software. You might think this is done by MTech or PhD, but believe me, this was done by, last time also when I came to this college, I told this is done by UG students. But we were collaboration with CXC and civil engineering students. You can click any bridge, project 1, project 2, project 3, and we can check whether the bridges are vibrating. If the bridge is vibrating, how much are they vibrating? Whether the vibrations are in permissible limit or not, we can check using this. Now right now we are doing approximately 15 to 16 bridges for the Indian railways. You might think that this is easy in the laboratory, but Excite, one of our student, PhD student, we were putting all our sensors and we are recording the speed of the train as well. It's very important. For Vande Bharat train, we asked us the train to go at 20 kilometers, 40, 60, 80 and 100. We have made it for 100, and if you see, this is the train with maximum load, coal and iron ore are the maximum load on the train. So we tested for 20 braking, 40 braking, 60 braking, 80 braking. So we generally put all sensors and we are trying to understand the behavior of the bridge. Anyway, I'll remove this part. Yeah, this is anyway the bridges. Now this is AI. Now the last challenge in India right now is because there are no engineers, I am telling in front of engineers, they are asking that there are no engineer who is able to assess masonry bridges. There you know you have lot of masonry bridges in India, at least 16 to 20,000 according to this we have masonry bridges. But there is no engineer who can tell whether these bridges can take new train load and speeds. So we were doing some AI and we were taking images and we were doing a lot of analysis. But still we have not submitted our report to India, it's still ongoing. We took around 100 bridges. You can see it is very difficult for us to walk inside this and measure or assess its strength. NDT techniques are very good for concrete and steel, but masonry structures it's very challenging. So MTech students what they did, we sent the drone, we took the photos and if you see we were drawing these lines. And we were using convolutional neural net. Anyway, we are using CNNs, I will not get into this. This is the AI. And this is called annotation. So by hand, can you see? By hand we were drawing. So we did like this around 4,000 images. It took us a long time to annotate. Annotate means you are telling computer this is damping, this is crack, this is spalling. All these damages you are teaching the computer. But after we taught this to the computer, what are these different kinds of damages? After that we gave 10,000 images to computer. Within no time of 2 hours, it gave us all kinds of damages, and it also did what it is also quantified the damage as well. So these are the damages we taught the computer using CNNs, and of course to increase the data we have to rotate the data because always site engineers might not take in the same direction. They take their camera in a different dimensions, and your computer should understand that. So this is called transfer learning. So you transfer images into different and then train the data. And this is what we train, this is actual, and this is what is the computer given answers. So these are the ones which we have told computer. After that the computer was giving these damages, which was giving approximately 96% accurate that these are the damages which are researching. Now you just send a drone to a location and then drone takes all the images of a masonry bridge and it tells us, okay, this masonry bridge has cracks, it has got a vegetation, it has got falling and it has got some pointing problem, everything. Now if we can know that, we can tell at least 20 or 30% of the bridge status. This is the ground truth and this is the predictions we did and we are doing on this. This is ongoing project right now. And this is another bridge of right now this is 99 100-year-old bridge. Almost you can see this, right? This is a 99-year-old bridge. I mean, Britishers have built this, and this is a steel plate girders. Now every train, once it is reaching to the bridge, you can see whenever you are traveling, the train is slowing down to 30 km per hour. If the train speed can increase to 60 km per hour, at least 4 or 5 trains can go on this much more. They can increase the traffic. So they asked us, is there anyone who can tell us whether we can increase the speed of the train on this bridge or not? Of course, we have did analysis. These are the matters. We did live monitoring of this bridge, and we did comparative analysis of all this. We told 4 or 5 piers have to be repaired, and after that they can allow train at 80 km per hour. Of course, they're still testing. Most probably by this summer, and we'll know that. So with instrumentation, we can tell till some extent 70 to 80% of the bridge health, and we can tell certain things with more of a confidence. But this also we have developed numerical model and digital twins also. Even though this took almost 1.5 years, I am just showing in a picture photograph. And this is Rajahmundry. I think you all know that Rajahmundry. I don't know whether this is real now. They are removing all these cables now, and they are replacing new cables. Now the last 6 months back when we were testing, we were going in a train. And we walked on the train. And while the train was going, the train was vibrating by inside. So which we felt that we can travel now, it's not a problem. But there was a small vibration in the wobbling in the train, and the driver every day was feeling that. So they asked us to test this bridge. So we have tested a couple of cables, and we have seen that if you, I don't know, sorry. Can you see, when you open one of the cable, I'm not showing because this is only, this is when you open one of the cable, just grouted with the concrete, but the grouting was not properly done. So these internal tendons, the rods inside the cables have actually broken. So some of the cables have become dummy. So we tested around 16 cables. Now there was another agency, you can see dynamic chains distorted, and these all around 16 we have tested, and we found that around 4 are completely dummy. So after that, now I think they are investing around 80 crores. 80 crores of rupees is not a small amount. So they are replacing almost 60 to 80 crores to replace all these hanging cables. This is called boasting arch bridge. So this also we did vibration analysis and did. And this, I think 5 minutes I will stop. And this last one, that is for masonry structures. This is for concrete. Similarly, like masonry structures, you can also send a drone, and it will take all the pictures of the bridge. It will tell these are the cracks, non-cracks. Now we are also able to tell multiple cracks. We are also able to tell the length of the crack, even width of the crack. Depth of the crack we are not able to tell. So this is all publications we did. But what I am trying to tell here is, now we can send a drone and we can quantify the damage. We can put our sensors and we can tell approximately 70 to 80% health of the bridge. So I'll stop here. So what we are trying to do, we are just trying to talk to our bridges. So let's make our bridges talk by installing certain kind of sensors, so that from the day one we know how the bridges are getting strengthened and how they are actually deteriorated. Once they are deteriorating, we know much earlier, or we can avoid accidents. So this is a small part of our research, ongoing live case studies with Indian Railways. So this is what small presentation from my side. Afternoon. If you have something, 1 or 2 minutes, I think I have time. So if you have something, you can ask. But this is ongoing. Even Vijayawada, that flyover is still going on, and this Rajahmundry bridge is going on, and we have some.
Data is coming real time, or you have to calculate that?
No, right time. Only for 1 or 2 bridges we did real time. All other bridges, our team is sitting at the bridge. We have a server there at the site.
So every day they are downloading and
Yes, we have a server. We are not connected to the cloud yet, because the data is very, very, very huge. Too many sensors, too much of huge data, it's becoming a little challenge. So still working on it.
But you are getting all 3-dimensional
Yes,
vibrations.
vibrations are all in 3 dimensions, because we should also know whether it is undergoing the torsional or not. So that is one of the major construction things.
Because previously people used to have differential global position system for bridge deformation.
Yes, yes.
So
Even now also GPS position systems are there.
yeah.
But this, with the vibration, we are able to tell if there is any kind of sudden crack today. We are able to tell, okay, there is a damage when compared to yesterday. There is a damage when compared to 1 month before. So we are able to tell that, okay, today there is a damage which has occurred in the bridge. That we are able to tell. And if there is already damage, we are able to tell whether the damage is increasing or not. So we are able to the damage is increasing or not.
So simultaneously you are collecting load as well as these three-dimensional vibrations also.
This is actually technical. We do free vibrations.
Okay.
We do something called free vibrations. We stop all the traffic. We get the free vibrations.
Okay.
And then we have the forced vibrations. Forced vibrations, we just generally see whether it is matching to the resonance frequency or not. If it is meeting resonance frequency, then they undergo severe
In
cancers.
future, maybe probably we keep a camera since we have a traffic analytical
Yes,
tools
yes.
also there. So we can correlate it. So whenever traffic load is we are assessing, so it is very easy to correlate with that.
I think that method is already there. As he was also saying, morning, DIC, digital image correlation. Digital image correlation is already there, where from the camera itself, people are able to measure the vibration and displacement. So they are able to do that. But the kind of accuracy they are still working on it. That is part of the geospatial technology.
Yeah, that's what I was correlating. I used to work on DGPS. That's what I was.
Yeah, this is also part of smart sensors. The concrete itself is made smart. First project is being done in Bihar. I don't know, last 3 months back there was a cable stayed bridge which failed during the cabling part. So now the government has insisted to put sensors during the construction itself so that we'll know before it's getting failed or damaged. Okay. Yes.
You can use the sensor while concrete also. They are only initial stage only.
Yes, I have not covered. This is a small presentation, but this research was done from last 8 years. It's easy to tell in half an hour, but it took more than 8 years. Almost now 9 PhDs are working on this. Which we have this sensor. That's what I was telling. Suppose I put a sensor here in this concrete. What is the amount of area it can tell, and how many number of sensors I have to put in the concrete? So we have seen that our piezo sensors are doing for 1.5 meter by 1.5 meter. In that cubic, we can tell what is the strain or strength gained by the concrete. But beyond that, it is becoming challenging. And while pouring the concrete, we have to be very, very precise that sensors doesn't get damaged, because piezo sensors are very, very sensitive. If you spoil the piezo sensor, it will not work. Something like that. So very, very sensitive sensors. So maybe tomorrow, like Burj Khalifa building has got only 16 sensors. Burj Khalifa building has only 16 such kind of sensors, and they've been doing live monitoring from the day of construction. They have around 50 piles of 50 meters deep. So they kept pile foundation also. They kept these embedded sensors in the piles, and they've been doing this monitoring from the day of inception, and any kind of huge winds, any kind of seismic waves, they are able to tell. They are able to control actively that sensors, and they are able to know everything about the building. After studying that building for 15 years, now they have decided that at least let's go for another 10 such kind of buildings. So something like that. So this kind of data research gives confidence that yes, we understand the behavior of structures.
Yeah, one more question, sir. Now,
Yes.
how many years that I can leave a sensor like that? Because you said.
At the end of the day, brand, very good HVK company brand companies give us the 30 years of life for the sensors.
Okay.
But since not many have been tested, 30 years is the maximum. After that, what will happen is you don't need to put sensor inside the concrete at all. You can put the surface mounted sensors.
Okay.
Two types of sensors. One is embedded, one is surface mounted. Again, after 30 years, we already know the structure. Now we put on the structure.
Okay. In India, any of these projects?
Yes, there is something called Prayagraj. There is a cable stayed bridge which is being censored. Sensors have been already kept.
Which is embedded into.
Embedded in the concrete and the cables as well.
Okay.
So cable to the tendons, they have stitched the strain gauges. So we can see the data continuously. Prayagraj, that is one. Now we are putting in Patna another cable stayed bridge. We are doing that. So for railways, there are 17 such kind of bridges which are 60-year-old steel open web girder bridges, including here Vijayawada Railcom Road Bridge. They wanted to put these sensors and see whether they can allow this train for 200 km per hour. Trains are being designed in India for 200 km per hour and for 32 wheel time. Now it is only 22. They would like to increase by another 10. So somebody has to test and then, right? So if you can give us the good product, then yes. Yeah. Anything else? Anyone? After afternoon, right after lunch. Anyway, thank you so much once again for giving me this opportunity to share our message. Thank you all. Thank you so much.
Thank you very much, sir. At international conferences, 15 plus at national conferences, 40 plus publications in well-reputed international and national journals, and a monograph titled Speed Detection and Management and ITS Application with numbered publications, UK, and authorized 2 books chapters as well. We are privileged to have Professor Paragirish Garu share insights on transportation research and case studies.
Thank you very much.
Very good afternoon to one and all. Firstly, I would like to congratulate the organizing team for hosting this first International Conference on Materials Innovation and Sustainable Infrastructure from the Department of Civil Engineering from Vishnu Institute of Technology, Bimora. And then I extend my sincere thanks to the organizing team for having me here as one of the keynote speakers for today's day one. And my presentation here is on transportation research and case studies. So where I'll give you the brief introduction about transportation engineering, how important it is at present and in past and in future. And then there are some case studies that we have done through our students as a part of their intern program or maybe as a part of their dissertation at the NIT and CSIR, CRI New Delhi. So moving forward, this is a brief outline of my presentation. So I will be saying the intro part about the transportation engineering and then take you through some of the important topics that one can focus to do as a part of their project work. So some of the transportation research topics we will see, and basically we will talk about have a discussion on level of service concepts, maybe for urban and rural roads, and also we'll talk about various LOS with respect to pedestrian, with respect to bicycle, and some compatibility concepts and all. And then later we will see some of the case studies. I have presented 4 case studies here. 2 is on level of service, 1 is on compatibility, and 1 is on emerging AI approach to assess the payment condition. So moving forward, so as I said, coming to the intro part, so this transportation engineering is well defined by the Institute of Transportation Engineers, popularly known as ITE. So as the application of technology and scientific principles for this, planning, functional design, operation and management of facilities for all modes of transportation in order to provide safe to rapid and convenience, comfortable, economical and environmentally compatible movement of both people and goods. So one way it covers this planning aspects, another way it covers functional design aspect, operational management aspect. It also given due consideration on these safety aspects, comfort issues, of the public. And one of the most important aspect of this transportation is the economy of a country rolls on transport. Normally we say the transport is a major factor that you can boost up this economy of a country, for any country I can say. For example, you see this map, it shows the Indian road networks. So as per stats, so India is standing in the second position in terms of having the largest road network in the world after the United States. So it covers almost 85% of the transportation via roads. So that means we understand that there must be an adequate transportation network to facilitate public needs. Moving forward, so these are the various aspects that is very important. So having a proper transportation network gives good connectivity and gives proper safety for the road users when travel on a particular road section. And then we will have efficient transportation facility, also having a proper transportation network, and then good accessibility will have. Of course, we will have a critical part in improving our tourism and recreation activities, and then we will have a good resilience towards this road infrastructure, and then we will have a certain improvement in urban development, and then we have a lot of things, and therefore we should have a proper kind of a road. When any new pavement is constructed, we have to ensure that it should have a smooth, comfortable travel, and it gives a compatibility for different diverse mode of transportation, like you say two-wheeler or four-wheeler. And then, so moving to the transportation research, I would like to highlight three important things. One is congestion and delay, and one is vehicular pollution, and one is the other payment failure modes. So coming to the congestion and delay, as you know, the recent literature or the past literature focuses and finds this congestion mitigates the metropolitan growth. As you see, different metropolitan cities in India precisely have lots of congestion issues, and because of the congestion, you have a lot of traffic delays. Because of the traffic delays, certainly people get so much of get into emotional. People even despite loses their emotional balance also in the traffic. So there are certain things where people can focus to address these issues. So people can focus on working on traffic congestion and the effect of traffic congestion on the economy. And there is one more term I kept here, airport congestion. So the airport congestion means, for example, there is an airport which is given a slot to an aircraft. So if that aircraft don't operate on time, but somehow it gives some delay, so it obviously prevents another aircraft to use particular time slot in the airport. So therefore, airport congestion is a major challenge issue as per the international air authorities, air transport authorities, and then that's how you can also focus on addressing the congestion issue in the airport. And then what are the different factors that affects the traffic congestion, and then some important measures that we can give to reduce the traffic congestion. And these two parts is very important. One is congestion and delay indexes, where two examples I can say Bayesian network approach we can use to determine this congestion and delay models, where you can able to identify percentage of delay during the peak hour, percentage of delay during non-peak hour also. So to understand the congestion severity on a given road section or traffic stream. So this is related to the congestion and delay aspects. And moving to the accident part. So as I said, accident is also another very important challenging, which is quite alarming at present in Indian conditions. You talk about the statistics of these accidents. So globally, India is standing in the first place, having more fatalities as compared to other countries. And then there are many reasons. For example, most of the people are aware of the traffic laws, traffic regulations, and all. But it is, but only the laxity on the part of the road users that leading to the crashes and leading to the accidents. So therefore, it is understood that these road accidents are majorly because of the human errors. So therefore, there are so many studies done by the many researchers, and highlighted that overspeeding is a basic need of basic cause of these road accidents. and this drunken driving, distraction to drivers, headlight jumping, and illegal movement across different topics, etc. All these are different causes of road accidents that people form from various research. And then there are different factors. There are certainly different factors of roads that contribute to accident. For example, you talk about passenger, you talk about drivers, you talk about the vehicle, you talk about road condition, you talk about weather condition. All these are the factors that have significant influence on the that contribute to the accident part. So certainly with all the studies, you can also focus to give some remedial measures to reduce the accident rate or reduce the severity of accident or reduce injury severity and so on. Certainly we need to conduct road safety audits also timely so that we will understand the growing nature of the travel pattern or growing the nature of use of motorized vehicles by the public and so on. And then another important aspect that one should focus on understanding the vehicular pollution. So one is the vehicular pollution. It is very much harmful. It has having an immediate reaction as well as it is having a long-term effect as well. For example, you talk about people's health. So most of us really not mind how this is affecting human health. So certainly in long-term situations, people are getting affected with their having a liver diseases, heart diseases, or maybe respiratory diseases. All these things are having certainly because of these pollutants which are releasing from the motorized vehicles. For example, you can talk about pollutants like particulate matter, volatile organic compounds, or maybe nitrogen oxide, carbon monoxide, sulfur dioxide, and all greenhouse gases that are releasing from these vehicles on the traffic. So certainly vehicular pollution affects on human health as well as how it is disturbing the ecosystem is one important element that one should focus so that we can address differently, we can give certain measures to address these issues. So moving to the another important aspects of pavement failure. So normally pavement failure is because of various variable indicators or variable parameters. For example, you talk about water intricity into the pavement layers, or maybe the second aspect is the stress that is caused due to the heavy vehicles, and the expansion and contraction of from the seasonal temperature changes, and also because of the sun exposure. So all these variables are impact giving the pavement failures. So it is very much important for us to understand to have a proper maintenance for the crack, and having a asphalt sealing so that you can able to prevent that crack to spread over the surface, or maybe the crack formation into the major pothole. So that's where you can prevent those things. So time is very important, essential element to have this pavement failure. So that's where the role of time is essential in ensuring safe travel. So these are certain parameters that gives this pavement failure: weather reaction, traffic load, inadequate maintenance, subsurface issues, chemical exposure, and the natural causes and aging factor. So these are certain distresses that I have mentioned in the slide, which normally that flexible pavement is having. So alligator cracking, block cracking, edge cracking, patching, potholes, traveling, rutting, and showing are the common distresses that pavement is exposed to, which is a particularly flexible pavement. So therefore, the absence of this distress obviously gives a better life for the pavement, also better convenience for the people, road users that uses. So this is where I mentioned two things here. One is transportation planning and one is traffic engineering. So we all have a scope to work on multimodal interactions. We can have scope on working on management and control, safety, and planning and all these things. And moving to the non-motorized transport and motorized transport scope of research. So particularly mentioned here. So there is a lot of scope to introduce a variety of traffic studies. Normally we do traffic studies by conventional methods that we see typically in the textbook, but we can also focus to bring new techniques, and then we can also focus on work on the geometric design of road elements, and then planning and analysis. Moving forward, then some of the research topics that are mentioned in the slide. So one can work on travel demand modeling and one can work on optimization techniques in routing problems, because it is very much important. One of my students also working on optimal routing of emergency vehicles using AI technologies. So this is one best example that somebody can also work, so that you can also be a reason to save someone's life. And then people can work on micro simulation, fuzzy approach, genetic algorithm, AI and GIS application, transportation modeling. So and then some of the important rising trends is intelligent transport systems, and the study about the autonomous vehicles, development of a simulation platform for safety impact analysis, and then traffic emission study, and building a good environment and travel behavior connection for the road users. And then some of the example of non-modal transport. One should do the questionnaire survey, because you need to understand the public perception on the current traffic situation, and also rising demand of the travel of the people. As you see, so many people are migrating from one place to another place for many reasons: for recreation purpose, for food, for shelter, or for security. So many reasons. People are moving from one place to another place because of migration of the people. Gross demand of the transportation also. So because people start using their own individual vehicles rather using the private public transit. So those are all the elements. So you need to understand the perception of public on these things. So questionnaire survey is the first thing we prefer to do as a part of the study, and then we also do the field studies. So after questionnaire survey, through videographic survey or physical surveys, and then after that we also do some simulation study. We have certain basic tools. Maybe you can talk about Sumo tool, you can talk about Vism, you can talk about Kenpev. So you can talk about different tools that are available to do simulation for traffic as well as simulation for the payment. Okay. So when you talk about pedestrian nature, we have certainly pedestrian crossing behavior, walking behavior. You can focus by understanding this: walking speed of pedestrian, crossing speed of pedestrian, arrival pattern of the pedestrian, compliance behavior of the pedestrian, risky behavior at junctions and crossings, conflict with other vehicles, motorized vehicles, and the gap acceptance behavior particularly at signalized intersections and unsignalized intersections, and then particularly level of service that is given to the pedestrians, and perception of safety, comfort and convenience to the pedestrians. When you provide a separate NMT facility, when you don't have an NMT facility, so suddenly there is a big difference that I will show you as part of the case study. And then when you do the research on this pedestrian crossing behavior, walking behavior, all these elements we consider as a design facilities. One is pedestrian volume, density, space, and fundamental relation between this density, flow and speed. And then signal time design, signs, markings provided for pedestrian awareness. All these elements will consider as one of the design facilities for doing research on pedestrian crossing behavior, walking behavior. And then as I said, level of service is one important concept that one should be aware of. So level of service is for roads, level of service is for bicycles, level of service is for vehicles. So when we talk about level of service, level of service is nothing but it gives a quality of traffic service given to the road users. So precisely you can say it's a kind of a measurement that provides an operating condition on a road segment for a road user. So certainly we have certain different manuals, like we follow highway capacity manual. So as per the highway capacity manual, this level of service is classified as A to F, where A indicates very good operating condition for road users to use that rural road or urban road. So where F is the least possible operating condition for a road user to use such road segment. So this we have on the basis of volume to capacity ratio. So volume to capacity ratio is something that gives the level of condition. So based on the level of condition, this level of service is given as A to F. So that is one element, this is one factor that gives this level of service. And another factor, we have speed also, that we will see in the coming slide. So here as per the manual, so you can see vehicle to capacity ratio, which ranges between 0 to 0.6. We have a free flow condition where there is no observability having any non-movement of vehicles. You have a vehicle with maximum speed. So similarly, it goes from 0.61 to 0.7 and goes until greater than 1. So the least possible operating condition is this. This is the worst condition for any road user to travel on such a road segment. So moving forward, as I said, the main LOS takes different elements. One is density, speed, delay, and speed, density, delay, speed, and then it will have based on the uninterrupted flow and interrupted flow. This LOS is classified based on signalized intersections and unsignalized intersections. This LOS is also classified into from A to F. So this is the table that you can see when delay is less than or equal to 10 seconds per vehicle. So you can see it is you have a little delay and no delay. And when your vehicle is having a delay from 10.1 to 15 seconds per vehicle, so it is classified into B LOS, which means it's a short delay like this. So the total based on the delay concept for the unsynchronized intersection, synchronized intersection, this LOS is classified into A to F. So you can see the condition, the picture that represents the different level of services, level of A, level of service A. There is no vehicle obstructing from another vehicle, or it is having free flow conditions, so vehicle can go at its maximum design speed. So level of service B with reasonable free flow condition. So level of service C with stable operation condition. So like this, if you see level of service F, most importantly, you see that metropolitan cities during peak hour, you will get this kind of situation where you takes a lot of time, not even more than an hour to travel a kilometer. So which is very important issue to address. So certainly these are the tables that shows the numbers. So this is all based on the vehicle per kilometer per lane. So if you have a 0 to 7 vehicles per kilometer per lane, so the velocity this is the maximum velocity that vehicle can afford to travel, and this is the vehicle to capacity ratio calculated for this category, and that category comes under A category. So like this, so you have a vehicle per kilometer per lane, velocity of the vehicles, and vehicle to capacity ratio. So as I said, vehicle to capacity ratio is the level of condition that you define through vehicle to capacity ratio, where you will take the number of vehicles per day into account as well as the capacity of the road into account to calculate this vehicle to capacity ratio as per the HCM. So again, this is another category of classification level of service based on different operating characteristics that I'll move directly to the case study. So these one important factors that you need to keep in mind which affects the level of service. One is the roadway factors. So what are all the things that comes under roadway factors? One is the laneway width, one is the lateral clearance, shoulders, surface condition, alignment and grids. And another important factor that affects the capacity of the road and the level of service of the road is traffic factors. So speed and travel time and delay also. Freedom to travel with desired speed, driving comfort and convenience, and operating cost of the vehicle as well as the road also. So, so as I said, level of service is for different roads. Right? So it's for freeways in rural areas, 2-lane rural highways, urban streets, multi-lane rural highways, different level of services, grades with different characteristics and its values. Moving to the case studies, these case studies were conducted at with different collaborations. One is with NITTC and one is with CSR, CRI in Delhi. So first case study we will see on level of service for urban and rural roads, the case study of Vishnu. So and then the second case study is on the design of cycle tracks for urban arterial roads, which is a case study of Trichy. And then assessment of pedestrian road crossing behavior under heterogeneous traffic conditions, which is a case study again of Vishnu. And then prediction of PCI, pavement condition index, using machine and deep learning techniques, which is a case study of Vishnu district. Okay, so we'll see all this thing on the board. So this is the first case study. You can see the pictures that shows this. This is the study area which we selected as cluster 1, 2, 3, 4. So College Road, Undi Bypass Road, and things like that. Then where we were able to find the LOS for all these things based on the volume to capacity ratio, and we define the LOS. So if you look at this table which is given by the highway capacity manual, so different classes and different categories. So if you look at these 4 clusters which is our case study, which is our study area. So you can see level of service is obtained at D, E, D, which means it is not absolutely have a good condition for a road user to feel comfort and convenience when one can travel in that road segment. So therefore there is a certain necessity to improve those roads. Okay, so this is another case study too, where it is a design of cycle tracks in urban arterial roads, which is a case study of Trichy. So we have opted for a 10 kilometers road stretch where almost 7 schools are located. So it is which we found there are so many conflicts between motorized transport and pedestrians and with motorized transport. So therefore it is we propose that there should be necessity to divert the motorized transport and non-motorized transport separately, so that we can improve the no conflict things and also movement of people with less delays. So as a process of this study, so people did this volumetric study where we were able to understand the traffic composition in different areas that we have selected. So during peak hour and non-peak hour, and as well as per day traffic. So we also seen the speed frequency of different categories of vehicles in these 4 roads. We have seen very maximum amount of vehicles traveling with very least speed, like 10 km per hour, 5 km per hour, 15 km per hour, which means there is a very much necessity to enhance the road facility for the road user. And then this is how this bicycle level of service given based on the manual. So bicycle level of service grades defined from A to F, and this is given based on the score which is less than 1.5, which means it is having excellent bicycle environment. So bicycle level of service is something. It is also given the quality of cycle is quality of service given to the bicycle riders when they are using that road segment. So that gives with this bicycle level of service. So similarly, if you take B grade, you have a bicycle level of service score from 1.5 to 2.5, like this. Different numerics and different grades defines different status of the road condition for the bicycle vehicle. So this is the model that you can see different cross sections are taken for a given road stretch, and a proposal network is also given for a separate non-motorized transport that you can see here. So these are the first three are the existing cross sections. The fourth one is the proposal network to improve this bicycle level of service. Similarly for the other road, the first one is the existing cross section, the second one is the proposal cross section. So I'll show you how this proposal network has improved the level of service from one grade to another grade. So this is the table that you can see the different bicycle level of service scores, and with respect to the score, different grades. So these are the certain roads that adopted for the case study. So finally, which we want to tell you is this one. So if you look at this existing road and proposed road, so we have a different grades here, D, E, D, E, and therefore with proposed network we were able to improve the level of service for these certain roads from D to C, B to C, D to C, and D to C. This is how we can have this one. So similarly, with the simulation, we have done validation also using Sim. So if you see without cycle track and with cycle track, the amount of delay happened for the vehicles and the travel time taken to travel for this 1 kilometer stretch. So it is almost taken 82.3 seconds without cycle track, whereas when you propose the cycle track and separate the non-motorized transport from the motorized transport, reduces to 34.6 seconds. So therefore travel time also reduced from 144.7 seconds to 83 seconds. So therefore whatever the proposal that we made is validating with the simulation also. Okay. So this is the third case study. Similarly, we have done pedestrian crossing behavior in Vishnu. So you can see we understood the nature of pattern for the pedestrian walking at different sections. So we were able to find this level of service for the. So with this level of service and other other severity of that we have proposed to the authorities as well. So moving to the last case study. So which I want to focus to tell you that how AI technology have been used to identify this PCA. So we normally have three different stages to assess the payment condition. One is the visual evaluation we see. We go to the field, we inspect through our leg bend. So that's how we do visual evaluation. And then functional evaluation by means of having payment condition rating, payment condition index, and present serviceability index. And then structural evaluation. So PCA is nothing but it have 0 to 100 on a scale where 100 indicates a better payment condition, where 0 indicates least condition for payment, very bad condition for the payment. So actually this PCA we calculate manually following this standard code ASTM G643323. So this this code we use for different practices like for road practices, for parking lots and payment condition index surveys we do. So this is one of the network survey vehicles we use to identify different distresses for the payment. So how this PCI is calculated manually? This is a flowchart that you can see. There are 6 stages. One is you need to go to the field and insert the payment and then select different sections. So you call it as a sample unit and then collect the data using your network survey vehicle. So network survey vehicle you can carry through the payment and then each sample unit you stop there and then you take all the types of distresses. So like that you collect the different data using network survey vehicle, and then soon after the collection you can try to assess that what type of distress is that and what is the severity of the distress, and so that. So you can assign the ratings for the distress. So we used I'll take 2 minutes to wind up this. So we have used 2 models. One is M5 prime model, one is PSO and LSTM model. So using this M5 prime model and PSO particles form optimization and long-term short-term memory network algorithm, you are able to find out PCI and compare this PCI with the obtained PCI which was calculated manually based on the ASTM code. You are able to arrive. This is a heat map and this is a scatter plot which shows the impact of 8 different distinct distresses on different distresses on PCI, which is a target variable here for us. So you can see the dense part, which means it is having a good condition, it is a very less dense, which is having a very bad payment condition, etc. So finally, we want to tell you that using M5 prime model PSO LSTM algorithm approach, you are able to get a 0.97, 0.957 and 0.97 as a regression score, which means it is almost giving a best result for predicting the PCI value on par with the manual calculation. Also, we have used another different algorithms like decision tree, linear regression, k-nearest neighbors, support vector machine, which are also different algorithms under AI. So comparing all these AI technologies, we say M5 prime and PSO and LSTM algorithms use the best regression score to find out the payment condition index. So which anybody can adopt and predict this, because manual calculation is very complex, because every simple unit you have to conduct multiple complex computations. So therefore, using this approach, it reduces the manual human interventions, the errors caused by the caused during the computational process and all. So with this, I thank the organizers for giving opportunity to me to share this.